Hello.
Yes, sir.
Yes. So shall we start then?
Yes, sir. Yes, sir.
Welcome one and all here. Very good afternoon to all. Our today's respected resource person has joined, Dr. Sangeeta Chaudhary, ma'am. Welcome, ma'am.
Thank you, sir.
So, dear participants, we are with us today, Dr. Sangeeta Chaudhary, ma'am, who is currently working as a professor and head in Information Technology Department, Ramrao Adik Institute of Technology, Nehru, Navi Mumbai. She has completed her UG and PG in computer engineering in 1999 and 2008 respectively. She has earned PhD from IIT Bombay in Geospatial Data Security in 2016. She has 23 years of teaching and research experience. She has published 80 plus research papers in reputed journals and conferences. She authored textbooks titled Digital Forensic and Cyber Security and Law. This is one of the milestone in her achievement. Congress, ma'am. Dr. Sangeeta Chaudhary is IEEE senior member, IEEE GRSS and IEEE WIE member, CSI, ISRS life member and IST life member. She was chair of IEEE WIE Affinity Group, Bombay Section 2022 and vice chair of IEEE GRSS Bombay chapter during 2019 to 2022. She is manuscript reviewer of many Indian and international journals. She has been a conference chair, session chair, and reviewer of many national and international conferences. She has organized technical workshops and activities for UG and PG students and faculty under the umbrella of IEEE GRSS. She has delivered invited talk and conducted workshops in the domain of GIS, image processing, and cybersecurity. Her research interests include satellite image processing, pattern recognition, information security, data analytics, geographic information system, and high performance computing. Hearty welcome you, ma'am. Yes, please enlighten us with your technical insight today to all our participants. Thank you very much, ma'am.
Yeah, thank you, sir, for the warm welcome and the introduction. So just let me share the screen and then I'll start.
Yes, yes, yes.
I hope my screen is visible.
Yes, ma'am.
Yes, ma'am. Clearly visible.
Yeah. Yeah, so very good afternoon to one and all present over here. Before starting, I would like to thank IEEE Bombay section and all the collaborating organizations for giving me the opportunity to share a small knowledge I have on this particular field. So as the topic is mentioned, and it is the FDP topic is you will be studying IoT 360 degree. This is one of the what we can say part which can also be given the utmost importance when people are using IoT. So that's why I selected the topic as a blockchain of things. So here basically I'll be talking about how we can have a convergence of IoT and blockchain all together to provide a better security and to provide an autonomous environment for the people who try to use IoT in various applications. And I think over this week, you might have gone through many, you have already attended lots of talk by the industry person and maybe people from academia also on IoT. You people are already knowing how the IoT is working and like what are the different verticals in which the IoT research is happening and in what way it can be now taking part in everywhere. Just to give a small example, a smart city is one of the best example of the IoT this thing application, and we can witness or we can see that at many point of time in a real life we are witnessing these things. The basic concern whenever we try to use IoT, okay, the one of the concern which is the security perspective. So probably this is the one angle in which I will be talking about, and you might have gone through many of the things like from the network point of view, or from the point of heterogeneity, or maybe from the point of scalability, or maybe the issue related to the communication, or maybe the agent system which is being used over there. So here, this particular topic will be actually trying to focus on all these aspects wherein we can try to imbibe some kind of security perspective, and we'll try to provide a secure delivery of the data as well as the origin tracing of the data, which is very, very important nowadays. So the talk will be divided into 3 parts, as here basically the term is we'll be having IoT and blockchain. So first of all, I'll be just giving you a small emphasis on the IoT, as you all are knowing this, and then probably I'll be talking about what are the issues in IoT with respect to security. Okay, and then we'll see a basic perspective of the blockchain, how exactly it is working, and then we'll see how we can use the blockchain, in what way the complete IoT architecture can be modified so that blockchain can be a autonomous part or integrated part of IoT framework itself, and in what way this particular convergence is helping us to get more and more efficient solution when we are using IoT in practice. Okay, so this is the complete overview about the talk which I am trying to give today. Okay, yeah. So if you can see over here, as we know that many disruptive technologies are coming in market. Okay, so some of the technologies are very having some like we are having some range of impact of those disruptive technologies on our regular life, or maybe the applications which we are using. So if you see here, I have divided this into 3 parts. So first, you can see these are the technologies who are disruptive technologies and creating a high impact. Okay, and then we are having medium impact and low impact. So if you see, IoT is one of the technology which is having the high impact, because everywhere we are now see n number of application nowadays we are using which is involving IoT. Of course, automation and robotization, artificial intelligence, big data, these things are coming, and in the supply chain, or maybe in a particular way the business is being happening there, this is having a very good impact. Okay, now coming to the next category, if you can see like a medium impact. So here maybe you can see we are having a rapid growth of the market, and possibly here this is having a low impact on the supply chain. We can say it can be any supply chain. I put here agri-food chain, but it can be any supply chain. So the technologies which are in this category is the blockchain. Then we are having some satellites. Okay, or the data which is being generated by the satellites, and then we are having virtual reality. And when we are coming to the low impact, okay, so here it can be a broadband network, ICT, and platform for e-businesses. So now here what we are trying to do, we are just trying to converge one disruptive technology which is having a high impact with the other disruptive technology which is having a medium impact, and then we try to provide some kind of efficiency in the system. Yeah, so having said this, now as I mentioned, first I will be highlighting on IoT. So this is a typical stereotype definition of IoT. Okay, that we can say that IoT is a collection of the things which are connected in a internet, and basically the purpose of connecting those devices or those things are for communication and for exchanging data. When I say exchanging data, it can be also the control and some kind of information also. Okay. So basically here what we are trying to do, earlier people were connected to each other using a network. Okay. Now we want the things to get connected in an internet so that things can communicate with each other, okay, and they can speak with each other. So fairly we can have evolution which we have witnessed, okay, all the in the time frame. So we earlier, before internet, okay, as we were saying, pre-internet, so that was the era when human to human communication was there. Okay, then we are having some internet of content, and www came in existence, and that time we were communicating, people were communicating with each other with the help of internet. Okay. Then we are having internet of services. So web 2.0 was coming in picture, and then we have started using lot many services which are available on internet, and people are using those services for completing the task. Okay. Then we are having internet of people, where people are getting connected with each other via internet, and of course the one of the best example of this is social media, which we are using nowadays. Okay. And then after that we are having internet of things. Okay. So here we want machine-to-machine communication or machine-to-machine interaction with the help of internet. And one thing which I want to emphasize over here, that in every evolution, if you see in every phase, okay, here the network is there, and we want to do the things with the help of, or there is one keyword called as smart. So every time we just wanted to have this thing or use these things in a smart way. Okay. And if you see over the evolution, okay, nowadays, if you see, earlier we were using desktop systems, and we could able to connect with one desktop to another desktop. Nowadays, it is not necessary that you should have a desktop. You can have a small device, you can have a mobile device, you can have your iPad, you can have your PDAs, and they can be connected with each other. Also, you can have some of the devices, like you can have some sensors and actuators, and they can also be connected with this. So the best example which is being used is you are having a smart mobile phone and you are having a smart watch with you. Okay, so all these sensors are being integrated over there, and they are trying to have a communication with each other, with the of course with the application also, and they're trying to give you some kind of analysis on the information which they are collecting. So now, having seen this particular evolution of the IoT, okay, basically, as I was mentioning here, we are having two things, or we are having two categories. First is people are communicating with people. Then we have a evolution where people started communicating with the things, and that's how we can show over here. Okay, that here maybe we can have some ECG sensor, we are having motion sensors, we are having some kind of other sensors which are planted on the body, and then we are trying to communicate over the internet. Maybe the best example is the hospital system, or maybe the healthcare system, where you can have such kind of use case where the patient is having all these devices on wearable devices, and those are monitoring the patient's condition, and time to time this will be fed to through the maybe some of the intermediator. It can be fed to the server which is located at the internet, and maybe some kind of storage somewhere it is being stored, somewhere the analysis is being happening, and it will be giving you the final analysis of that particular thing. But this is the typical example of people are connecting with the things. Now we are having the another case, which is things are connecting with the things. So if you can see over here, so autonomous vehicle is one of the best example. Okay, so or maybe here you can see one particular system I can take, if for example, so this is an autonomous vehicle which is having all this kind of devices, and it is trying to get connected with many of the things. Maybe you can see some kind of like the petrol pump, or maybe some kind of garages, or maybe the police, or maybe we can say some emergency services, okay, like ambulance and all those things. So nowadays we are having all such sensors, okay, which are mounted on this particular, or they are autonomously working, okay, in collaboration, and they are trying to give you every ace of the use of that particular device. Okay, so sitting in a van, okay, or sitting in a car, okay, you don't need to really worry. Okay, everything will be taken care of, all these devices, and they are communicating with each other, and they are the complete system working in an autonomous way to take a decision. And of course here that's how we are having autonomous system working. So this is a typical example of things connecting with the things. Now obviously the question will come in your mind, okay, up till now this is okay, fine, all these devices are communicating with each other, but one of the basic thing which we need to understand over here is, whenever we have such scenarios where things are getting connected with things, okay, we are having lot many resources which are getting connected with each other, and they are not homogeneous. Okay, they are heterogeneous this thing devices. So this is one of the we can say a challenge in IoT also. Okay, that many of the devices are heterogeneous, and then we need to have a solution, or we need to have an infrastructure which will take care of the heterogeneity of the devices which are getting connected in the network. Also, if you see, as it is providing you all the solutions, okay, lot many sensors, lot many devices are getting connected, okay, and the processing, the information is getting generated from many of these devices, and they are getting exchanged to each and every devices which are required over there. And because of that, the complete resource management and information management is becoming complex. Okay, also if you see the network which is being used over there, okay, it's a combination of network. Maybe somewhere you are using Wi-Fi, somewhere you are using a mobile network, maybe somewhere you are using satellite network. So all these networks are having their own way of working, okay, and now we are trying to use those different networks over here. Okay, so now I'm probably thinking from the security perspective. So if we want to simply establish a security on the top of this, then all those things has to be considered. Otherwise, you cannot find out, or you cannot give a solution which can be typically solve the purpose, okay, for of this such kind of application. Okay, so I hope it is clear to the participants. Okay, yeah. So moving ahead, just to give you a flavor of the use of IoT in the current scenario. So if you can see from 2010 onwards, to it is giving you some this thing like the predicted value also. So till 2025, if you see the use of IoT devices, okay, over the non-IoT devices is fairly getting increased. And if you see now we are in 2023, so here it is showing 19.8. Okay, and if you see here, this is the particular market in terms of billions. Okay, and this many billions devices are currently in the network which are connected to each other. So you can imagine what will be the complexity. Okay, so basically, if you take a simple example of a smart healthcare, okay, so in a smart healthcare, there are many such kind of devices are getting connected to the system. Okay, and a lot many things, lot many devices are generating the data. They are feeding the data to the servers. The server is taking decision and again feeding it to the devices to perform the next action. Okay, so likewise, the things are happening. So if you see now, if we are having so many such devices connected in a network, okay, obviously here the question will come, okay, how do we have, or how do we establish the environment, okay, wherein all the users which are connected, or all the devices which are connected in the network, okay, they will feel that, or they will be having a typical secure environment. And of course here basically the data should not be leaked, or maybe some kind of attacks are happening over there, so such kind of attack should not happen. So all those things are coming in picture. So maybe in subsequent slide I'll be showing you those kind of challenges which IoT is actually coming up in the this thing usage of the devices over the years. Okay. Some of the challenges can be solved by using simple minimalistic security standards. But now, as we are using IoT not only for small application, we are using this as a complete ecosystem. Okay, so therein only usage of some small encryption, the security standard will not help. So we should have a complete a complete system which can work at all the levels and will give us a solution, okay, so that we can rely that yes, this is the particular system which is providing us foolproof security of everything. Okay. So yeah, so now before seeing the blockchain convergence into IoT, we need to understand how exactly, what are the different layers in which IoT is working. So this is a typical, very stereotype architecture of IoT. So probably we are having 4 layers over here. The first layer, which we are seeing that this is the layer called as hardware layer sometime, and this layer is actually comprising all the sensing devices, okay, or we can say these are the sensors and actuators which are basically being connected in a network. And on the top of that, we are having a network construction. So as I mentioned here, we are having heterogeneity in network as well. So you can observe here, we are having heterogeneity at the sensing and identification layer. Okay, sometimes it is called as acquisition layer also, and then we are having the heterogeneity in the network layer also. Okay. And on the top of that, once the data is being collected, maybe you can take an example of again the wearable devices. So those are connected with the maybe some server in cloud. So the data is being captured and that is being passed from the device to some server. Okay, and from that server, now it will be fed to some engine where some kind of processing has to be done. Okay, so on the top of this network, we are having information processing layer, wherein we can have data centers, we are having search engine, maybe we are having some components which are helping us in taking smart decisions. Then we are having the information security component also. So as I mentioned, we are having basic security enforcement over there, which is helping us in the in establishing some kind of security at this particular layer also. Okay, but this is not sufficient. Okay, and of course, then we are having the on the top of this, we are having application layer where we can have like the integrated environment, maybe a smart transport, or maybe the environmental monitoring, or a smart healthcare, or maybe a smart city, or green building, or smart grid, and whatnot. Okay, so all such applications. So this is a typical architecture. So maybe you have seen how these things are working. Okay, but now here this thing like the as we are trying to incorporate, or we want to converge blockchain inside this IoT. So basically this particular architecture need to be modified. So we'll be seeing that how exactly this architecture will be modified and what kind of components need to be added over there, so that we can have a seamless, secure environment, okay, which can be used in such kind of applications. Okay. Yeah, so coming to the security challenges, so we have seen that now we are having heterogeneity in network, the devices, we are having heterogeneity in network, we are having heterogeneity over here also. Okay, so now it is actually bringing the challenges, security challenges in IoT. Okay, so I'll be showing you one complete this thing categorization also, so that it will be helping you to understand. Okay, so very first thing is a lack of standardization in IoT. So basically, if you see, there are many devices are getting connected, they are heterogeneous, and maybe their working, their pattern, their use of or style of working, the protocols which they are following, they are different. So basically, whenever we try to connect all such kind of heterogeneous devices, okay, there should be some standard operating procedure, or there should be some kind of policies which need to be followed, or standardization. But in most of the cases in IoT, okay, as different people are coming together. Say for example, I am taking a smart city. Okay, so in smart city, there are many components. Okay, I can say a smart garbage management is one component of smart city. A smart lighting is another component. Maybe a smart rainwater harvesting is the third component. Then we are having smart transportation as the fourth component. If you see, all these different components will be managed by a different organization. And basically, they do not have any kind of mutual communication among them. So of course, they will be using their different terminologies, their different ways to establish the thing. Okay? But when we are looking this as a single entity, as a smart city, Okay, so there should be a standardization which should be applicable to all such kind of components so that they should work in a seamless way. Okay, otherwise it may so happen that if one system fail, okay, or maybe if it is connected with the other system and something goes wrong in one system, the other system will get affected, and many things can happen. So that's why here this is one of the basic problem in the security of the IoT. Okay, that there is no standardization or lack of standardization. People are trying to do the standardization, but still there is a lack of standardization, and because of that it may introduce many of the vulnerabilities in the network itself, in the IoT framework itself, and it is actually attracting the attackers to launch the attack on it. Okay, so that is one thing. Second thing is weak passwords. Okay, so most of the people, as they are using IoT, okay, so sometime it may so happen they either use the password which are very weak, or they normally tend to use the password which are default passwords always. Okay, they are not taking care of changing those passwords and all. So maybe this is one problem. We cannot say it's a crucial problem, but because of this problem there may be some kind of attacks happen. And if you see, might be in the recent years you might have seen there are many attacks happens on electrical grid. Okay, so the some of the attacks are happened or were happened because of the reason of weak passwords only. Okay, and of course then we are having insecure network. So as the pillar of this IoT is the backbone infrastructure, backbone network infrastructure which you are using. So if there are some flaws, there are some vulnerabilities in the network itself, definitely the complete IoT system as a whole, it will not work in proper way. So this is again a challenge as we are using multiple heterogeneous networks over there. Okay, so sometime it may so happen that the applicability of one security standard may not be useful to the other network infrastructure, because their protocols are different, their working is different, their vulnerabilities are also different, or maybe the problem occurs when the users are using them, and because of that the attack can also be possible. So this is one of the challenge in the IoT. And of course the last challenge is IoT malware and hacking. Okay, so some of the devices, if you see, these are the hardware devices, maybe sometime they are having some firmware also. Okay, and it may so easier for the attacker sometime to hack those IoT devices. And if one of the devices is hacked, then through that they can penetrate inside the network, and they can eventually try to make the attack more severe. So if you see, most of the time in the recent years, okay, people are finding the cases of getting that IoT network as a like the attack they are doing is the maybe some kind of attack they're putting, and they're trying to make that network, IoT network, as a zombie network, so that it can be used for some for doing some other kind of attacks over there. So this is one of the crucial attack which is happening on the IoT. Okay, so these are the security challenges which are being there. And to show you the specific attacks, I'll just try to show you one file wherein I can just show you the attack also. Just give me a moment. So I will just try to show you what kind of attacks are actually happening on the IoT, and then possibly I will be showing you also how we can take care of, or how the blockchain will be helping us to get rid of those things. Okay, so let me just share my screen one more time. I hope my screen is visible. Can I get a feedback?
No, madam.
It's not visible.
Yes, right now. Yes, madam.
Yeah, it's visible now, right? Yeah. So here, if you can see, I was just mentioning about the different layers of the IoT architecture, and in every layer, okay, there are some kind of attacks which can be possible. So, like from the perception layer, if you can see, this is the probably the last layer. So, if you can see now, I'm just trying to show you. So, at the perception layer, where we are having the hardware devices which are present in the IoT this thing architecture. So there are lot many attacks which can be available over here, like which can be launched by the attackers over there, like the jamming adversaries attack, node capture attack. So the complete nodes are making victimized, and the node is fully controlled by the attacker. Okay, and they are trying to such multiple such nodes are getting captured, and the complete network gets emulsified them. Then we are having insecure initialization. Some of the nodes which we are using, node means the devices which we are using. So whenever we want to use them, they need some kind of initialization, or they need some kind of default values or threshold values to be set. So here the attack is probably happening over there, which is trying to make the initialization in a emulsified way, so that it will set the values in the wrong way, and that will probably result in the wrong analysis which is being done with the help of those devices. And then we are having some of the general purpose attack, like the malicious code injection, or maybe the spoofing and Sybil attack, the false data injection. Sometimes the devices are working on some trigger action. Okay, so those particular trigger actions are dependent on what kind of data is being fed to that device. So here the data which is fed to that device, sometime it can be a false data, and the device will start working in an abnormal way, or maybe exactly in a reverse way, or the opposite way it is trying to act. Okay, so maybe you can say that we are having one relay which is trying to depending on and off situation, maybe some circuitry is getting started, or maybe the water pump is getting started. So you can imagine if it is working in a opposite manner, so whenever you want to start a pump, it will not able to start, and it will stop. It will so it is trying to do, or it will simply do the opposite action over there. Okay, and of course we are having some kind of attacks on the physical interfaces which are there between the devices, and the side channel attack, the sleep deprivation attack. So sometimes it may so happen that the emulsified code is injected in the devices, and that device will go on the in the sleeping mode automatically. So the other devices which are trying to actually contact that device, okay, because see, we know always in the network it is trying to send a signal, and within some specified time, if the reply is not being captured or getting answered, then again it will send a signal. So this is happening multiple times. Once the threshold is achieved, it will declare that the device is off, or the device is not working. Okay, it is in the sleep mode. So purposely, deliberately, this thing can be done. Okay, and possibly because of that, some of the functionality of the system is not working. And of course, we are having the evas dropping and interference. So these are some general purpose attacks, okay, which can happen on IoT framework, or we can say at the perception level, at the this acquisition level. Now, when you are going to the network and transport layer, okay, so here basically all the attacks which you might have seen in the network, those attacks can be possible over here. So it can be authentication, or maybe a communication problem. It may be a replay or duplication attack. It may be a session establishment, okay, and resumption, even though the rights are not there. The buffer reservation attack, some kind of sometime the privacy violation can also be there. The insecure neighbor discovery, Sybil attack, sinkhole and wormhole attack, and maybe here the transport level end-to-end security problem. Okay, so this kind of attacks can be possible. So along with the general purpose attack which are happening on the normal network, as here heterogeneous networks are also used. Depending on what kind of network you are probably using, this attack can be possible. So if you see lots of heterogeneity in the attacks also, depending on the layer, and if you see the application layer, maybe you are having some kind of the attack like the middleware security, or maybe the insecure firmware or software itself, or the interfaces which are using, they are insecure, and because of the attacks are happening. So if you can see here, just here we have done one study, and we came to know that these are the different security issues which IoT framework is dealing with, and now we want to provide a solution on this particular issues. Okay, so the other portion, I'll come back to this maybe once I complete this portion of the blockchain. So coming back to now the presentation. So as I have shown you, there are many such kind of attacks, and believe me, I have just included here few attacks. Okay, there are hundred thousands of such attacks, different attacks which can be possible, and now we want to provide a solution on that. Okay, so having said about the challenges of this IoT, okay, now we want to provide the solution. Okay, so basically we have seen, like in industry 4.0, if you see, okay, there are many things which are possible over there, and we can improve the performance of the system or efficiency of that system, of course, by enabling or by incorporating these two disruptive technologies. Okay, one can be the artificial intelligence, and second can be a blockchain. So if you see, we are having many things, like we are having supply chain, we are having the fintech, we are having the insurance tech, we are having manufacturing, we are having smart grids, we are having mobility, till you can see there are many applications, till smart cities and smart services. And we are having Internet of Things and Internet of, again, everything. And see, there are n number of different derivations which we have from IoT. So if you see all these things which are possibly people are working in the industry 4.0 to find out the solutions. Okay, basically in the backbone, now people have started using artificial intelligence, and people have started using blockchain. So you might have witnessed now over the period of years that how AI has captured each and every application domain, and there people are trying to provide you better and better solution with the help of artificial intelligence. But at the same time, the other perspective of this is, as you are having lots of devices you are trying to connect, lots of heterogeneous networks you are trying to use, lots of applications you are trying to use for taking the decision. Okay, what about the security of all those things? Okay, and of course here when I say IoT devices are connected, so if I say simple mechanism, one IoT devices that is capturing the data, sending it to cloud server. Okay, maybe it is sending to some receiver, okay, at the local site. That receiver will be sending it to the cloud server. Cloud server is doing some kind of processing on that data, or it will be sending it to some other server which is doing the processing, and from that particular server it will be fed to a application which is being used by the client. Okay, so if you see now in this particular scenario, you can have one chain of the one chain where you are exchanging the data from one party to the another party. Okay, so now if I'm taking this as a scenario, I have multiple exchanges of information. Okay, maybe from sensor, first exchange is sensor to the local receiver, then second exchange is local receiver to cloud, third is cloud to the processing server or a decision making server, and from that the fourth exchange is the decision server to the client. So in this particular communication, everywhere, okay, some or the other network is being used. Okay, so now whenever we are dealing with such kind of supply chain or such kind of chain of information exchanges, okay, is it really feasible to use a simple security standard, or we should have some kind of specialized technique or technology which can be helpful for us to secure the complete chain of operations or chain of the exchanges which is happening from the first device to the last device. So now obviously here we can say, so this is the question, and now the answer for this is yes, we can do that, and blockchain is one of the probable answer which can provide you the complete security from end to end. Okay, and that will establish the complete security over the path from one device to the another device. Now, of course, as I said, blockchain is being used, but obviously the question will come in your mind that how exactly the blockchain will be helping us to address this kind of security challenges which are posed in the IoT framework. Okay, so now the second section of my presentation will be dealing on, first of all, we'll see what is blockchain, how exactly it is working, and then we'll see how this can be useful or this can be integrated in the existing IoT framework so that we can solve the problem which we have seen now. Okay, yeah, so I hope it is clear. Can I get a feedback? Hello?
Yes, ma'am.
Okay, fine. So now I'm simply switching to the next, because unless until we understand what is blockchain, okay, we probably will not able to see or understand how exactly it is being when it is introduced in the IoT, how exactly it is providing a security and in what way it is making my IoT framework more efficient. Okay, so just to give you a very specific and very traditional definition of the blockchain, is a blockchain is, first of all, as the name is given, blockchain, it's a chain of blocks. Okay, we are trying to connect one block with the another block, okay, with some kind of mechanism, and possibly that block will be containing some data which we want to store or we want to exchange over this complete chain of exchange. Okay, so now typically we can say that blockchain, it's a chain of blocks and it's an append only. Okay, these keywords are very, very important to understand the blockchain. So it is append only, cryptographically secured, distributed and replicated store of records. Okay, now one very important thing before seeing this, if you see IoT environment, so sometimes IoT environment is being a centralized environment. Okay, because somewhere the control is there and from that the controlling is happening. Of course, we are having distributed IoT networks also. But if you see the core IoT that is working in a centralized fashion, but now we want to use a technology which can be integrated with IoT, but basically that technology is working on the concept or the base of the distributed computing. Okay, so that's why here, if you see, first of all, blockchain is an append only. Okay, you can add something into the blockchain, but you cannot modify the already present contents in the blockchain. Okay, that is one thing which we have to keep in mind. Second is, it is cryptographically secured. So some of the cryptographic mechanisms are being used over here, which is trying to give you the complete security solution. So it is cryptographically secured. It is distributed. So when we are trying to use this blockchain, okay, basically it is not being the process at one single machine. All the machines which are taking part into that will be again having the copy of the blockchain, and everywhere the processing will be, of course, the processing will happen at one node and then it will be replicated to at the different places. So that's why here the next keyword, if you can see, and replicated store of records. Okay, so it is a kind of ledger wherein you are putting a series of operations which are performing one by one. Okay, and then they will be secured. They cannot be modified. Okay, so maybe say, for example, I am going in market and I have purchased one, maybe some item, and possibly I got a receipt of that item and it was mentioned that it was 300 rupees. Okay. Now, certainly, as I mentioned, this is as it is put over there as 300. Okay, so basically, this is a transaction which happened between me and that seller of that item. Okay, now as it is on the paper, maybe sometime it may so happen I can just make that 300 as 800. It's so easy. Okay, but now if I am just trying to digitize it, or I'm just trying to use blockchain over there, once the transaction is generated at that 300 rupees ka item I have purchased and it is put on the blockchain, later on it cannot be modified. Okay, so that's why it is append only. And when I say, like, as I have mentioned here, these two things, cryptographically secure. Okay, so it doesn't mean that we are just using encryption and we are storing everything with the encryption. Okay, there are a lot many things which are being used over there. And store of record, when I say, this doesn't mean that all the data associated with the transaction is stored on the chain. So maybe people are having, this is one myth with people are having, that we can use blockchain to store huge records also. But basically, we cannot store huge records on the blockchain. Okay, we can store some kind of indexing of that data on the blockchain. Some small transactions you can store. Probably I'll be mentioning that in one of the subsequent slides. So here, when I say store of record, it does not mean that the complete data is with the transaction is stored on the chain. Very specific data related to the transaction can be stored on the chain. So let's understand how this particular technology is working, so that we can understand how we can integrate this with the IoT. Okay. Yeah. So to give you the basic understanding how exactly the blockchain is working. So as I mentioned, it is working in distributed fashion. Okay. So like whoever is involved in that particular process, okay, those are having copy of that particular records, okay, and everywhere it is showing you the similar record. It is like a consistent record is being stored. So this is a typical example which I have taken just to illustrate you. So maybe we are having 4 users over here, or 4 nodes, okay, or you can consider 4 machines. Okay, we are having Alice, Bob, Dave, and Charlie. Now, initially, Alice has deposited $100 in her account. So this is a transaction. This is one operation which happened. Okay. So now we want to put this on the blockchain, as this is the operation which happened. So now this is this particular transaction or operation. This will be added into the ledger of Alice. Okay. This ledger is nothing but it's account book like structure. So now blockchain is nothing but it is a distributed ledger only. Okay, where the copy of this ledger is available at all the nodes and it is in the consistent format all the time. Okay, so now Alice has deposited 100 rupees in her account, so that transaction is being completed. And now, say in the initial scenario, this particular transaction is available on the ledger. Okay, now maybe after some time, say for example, Alice wants to transfer 50 rupees to Bob. So the transaction is Alice to Bob 50 rupees. So basically here one more operation is happening. Okay. Now whenever this operation is happening, okay, the decision cannot be taken alone by Alice. Okay. The decision has to be taken by all the entities which are there in the network. Okay. So now when Alice is trying to send or trying to transfer this 50, so the transaction is Alice to Bob 50. So first of all, that transaction will be sent to Bob, that transaction will be sent to Dave, and that transaction will be sent to Charlie. And all of them will validate that transaction. Now, how do they validate this transaction? So everybody is having this record. Everybody is having this record with them that Alice was having 100 rupees. So validation means we have to check whether this transaction is correct or not. So now here, as everybody is having same entry in all the ledgers, okay, Bob can verify and say that yes, this particular transaction is correct. It is validated. Okay. Then next is come to Charlie. Charlie will also say Alice is already having 100 rupees. So sorry, $. So Alice can transfer 50 to Bob. Okay. And similarly, Dave can also do. Now, once all the people, all the nodes are validating it, then and then only this particular operation will be performed. So that is one of the very important thing in blockchain, okay, that everybody who are the part of that blockchain network, okay, they will be performing the validation of the transaction, and once the validation is successful, then only that transaction will be executed. Okay, so I'll be telling you this scenario in a different way, maybe in subsequent slide. So now everybody is saying that yes, the transaction is valid, and now the transaction can happen, and the transaction is Alice to Bob $50. And now in everywhere, in all the public ledgers, okay, this particular transaction is added. Okay, so this is a typical scenario. Now, say for example, next transaction is say Bob wants to send $30 to Dave. Okay, so earlier Alice was having $100. Now she transferred $50 to Bob. So Bob is currently having $50. So and Bob wants to send $30 out of that to Dave. Now here in this scenario also, as the transaction is happening between Bob and Dave for this particular amount, this transaction will be sent to Alice, this transaction will be sent to Dave, this transaction will be sent to Charlie, and even Bob. So all will be validating that with reference to this public ledger. So now if you can see now, as Bob is having $50, the transaction will be validated by him, and by her. Okay. And now as it is validated by maximum, or we can say majority, then possibly this transaction will happen. Okay. So now if you see the next transaction, this transaction happened correctly. Now one more transaction Alice has initiated. So now if you can see over here, now Alice has initiated the transaction, okay, and she wants to send $60 to Charlie. Okay. Now in this case, if you observe, Alice was having only $50 in her account because she already transferred $50 to Bob, and now she is making one transaction. So now here it is the responsibility, or it is in the network autonomously. Bob, this transaction will be sent to all the other nodes which are there in the network, and now Bob will be verifying that. Now when Bob is verifying, Bob will check this public ledger, and now Bob is verifying that yes, because Alice is having only $50, so Alice cannot transfer $60 to any other person. So obviously Bob is rejecting or invalidating that transaction. Okay, that means that the transaction is not correct, okay, or valid, and Charlie will also come to the conclusion that transaction is not valid, because here also the thing is it is showing $50. Similarly, Dave will also invalidate it, okay, because it is having only 50. So now here all these are saying that it is not valid, okay, and that's how it is genuinely valid. We can see over here, and now the transaction cannot be possible. So transaction is simply invalidated, and this transaction cannot be completed. Okay. So if you see from this scenario, okay, each one of this is actively involved in participating over here and finding whether the transaction is validated or not, or whether it's a valid or not. Okay, so this is one of the first thing which blockchain is providing, which is very important. Okay, so now if you see, if some of the party, you might be asking me the question that if some of the party is say malicious, suppose for example this Dave is malicious. Okay, malicious means here some entries are changed. Okay, so in that case what will happen? So normally even if this particular user or this particular node is malicious, okay, here the other two nodes are working. Okay, so now they are saying invalid, he is saying invalid, okay, and he is saying valid, for example, okay, because here some kind of multiplication is being done. So here, as I mentioned, the validation, when the result is coming to the originator of the transaction, okay, the majority principle is being used over there, and it is trying to check, okay, what is the majority. So here, if you see, if you are considering the node, so even if you are having 49% of the node multiplied and 51% node are genuine, then the network will work in fine case. So you can say that until and unless you are having 50% of the nodes which are multiplied, the network will not go in a wrong path, and it will still work in a proper way. Okay, and that is one of the concept which is being used in blockchain, okay, that it is called as 4951 or majority principle, and most of the times it is being used for taking the decision on this particular validation and all. Okay, so this is just the basic scenario to give you the basic understanding of how the things are working. So if you see, if the data is being the exchange is being happening between two parties, it is not merely the two parties which are getting involved in that, but the other parties are also there who are validating that. So if somebody try to do some kind of multiplication, it will not be possible really. Okay, so that is one thing which we need to understand. So by seeing this, you might have got the gist of how exactly the things are working. Okay, now coming to the real this thing. So maybe I just mentioned you what is blockchain. Okay, but now how exactly the blockchain is being used, or what kind of characteristics it is pertaining, which is very, very useful when I say I want to provide a complete secure solution. Okay, so first of all, as I mentioned, it is working on a distributed environment. Okay, so there is no centralized entity. So even if one node is failed, okay, the other nodes are there who are working in a genuine way. And so until and unless you are half of the network is working fine, 51% of the nodes are working fine, it will work in a fine way. Okay, and of course here the very important thing which we need to understand over here, which is the backbone of the blockchain. Okay, so actually just to tell you the evolution perspective of this blockchain. So in 2008 or 9, one anonymous a person, or it's a group of people, they are known as Satoshi Nakamoto, and he came up, maybe we do not know whether it's a single person or it's a group of people or it's an organization, but they come up with one terminology, and the terminology was how to use peer-to-peer communication for secure e-commerce transaction, okay, without having trusted third party. Okay, so basically they want the communication to happen between two parties only without involving any third party. So normally, say I want to transfer some money to maybe one of you, so I can transfer with the help of trusted third party, that is bank. But now we don't want bank to be involved in this, okay, and we want directly to perform the transaction. Okay, then how do we have a framework for that? So probably in this particular article they come up with a basic terminology, okay, which is being used for such kind of exchanges, and later on that technology or that particular terminology is being used as a base of the blockchain. Okay, and probably first time it was being used for the cryptocurrency, that is Bitcoin, and eventually then people started using it in multiple applications, and nowadays if you see, it is one of the mature system which is being used in many of the applications for providing better and better security, even though the entities which are trying to use this, they are not trusting each other. Okay, so that's why here one of the characteristics of blockchain is it is trustless. Okay, then of course here transparent. Whenever you are having this blockchain, okay, so that blockchain is available, you can read that blockchain. Okay, only thing is you cannot modify it, okay, but you can read it, and whatever the operation happens from beginning till the end, okay, you can observe all the operation or you can see the operation. So that's why being having that particular facility, we can say that it is transparent. Okay, then it is secure, as we're using some kind of cryptographic operations over there. It is just, let me just tell you that when I say cryptographically, it is not merely encryption. We are using other operations or other mechanisms also, and it is trying to provide you privacy also. Whenever the users are there on the blockchain network, they will not be identified by their names. Okay, possibly over the network they will be identified by the public keys which they are having. Okay, and that is actually trying to preserve their identity, and some kind of privacy is being achieved over there. Okay, so if you can see here, we are having this kind of a distributed already we are having. Then the digital ledger, so we have seen how at every user that copy is being maintained, and there the information is put. Okay, and of course here it is immutable. When I say immutable, whatever the things which you have written once in the blockchain, you cannot modify it. Okay, so as that's what I was saying. You have made a purchase of 300 rupees and a digital transaction has been happened. Once it is added into the blockchain, you cannot modify that. Okay, so that's why you cannot make the changes in the existing blockchain. Of course, if you want to nullify the result of that transaction, you can create one more transaction and you can nullify it. Okay, but you cannot modify the existing thing. Okay, because you do not have any permission to do the modifications or rewrite the thing. Okay, only you can write in a append mode only. So that is called as immutability property of the blockchain, and this property is making it very, very efficient and the secure one, and it is trying to help the complete ecosystem to trace the origin of the information or trace the origin of the operations from where they are coming up. Okay, so I'll be showing you one case study there. You can see how the things are working. Okay, of course it is auditable. You can see that who have done what kind of operation and all the things. So maybe probably I can just show you one this thing. Just let me go and show you so that maybe those who are not from blockchain can get some flavor of it. I hope my screen is visible. Yeah.
Yes, madam.
Yeah, so the probably you can see the blockchain. This is a blockchain explorer, and anybody can go to this site and see. Okay, maybe I'll just reload it. So possibly it is showing you the complete this thing blockchain, and you can see each and every block of that blockchain. You can see the complete details of that block. You can see the transactions which are there in the block, in that particular block, and all the details. Okay, so maybe some error is there. Let me refresh it. So if you can see over here, I'm just trying to show you two things. It is not coming. Okay. Maybe you can just Google for this blockchain explorer, and you can go to blockchain.com and see this. So it is trying to show you. Yeah, you can see over here. It is showing you the latest transaction. So I'm trying to show you in the for the Bitcoin. So it is showing you the latest transactions. These are happening. Let me just go. The network is very slow. Yeah, I'm extremely sorry. My network is not that much good today. But you can just go to this and you can surf. Okay, it is like all the things are there on the dashboard, so you can click and see. So you can probably see how the blockchain looks and the complete details about that blockchain. Okay, so I'll come back to this demo in some time. Yeah, so you can see over here we are having this facility, or we can say the characteristics as it is auditable. Okay, and one very important thing is the consensus. Okay, so whatever action has to be performed, or maybe I have just shown you the transaction validation has to be done. So there the common agreement has to happen between the nodes which are participating over there, and that is called as a consensus. So we know that whenever we want to take some decision, we are just asking all the people in the group, and we will be deciding based on what majority of people are saying. So similar kind of thing is being used over here. That is called as consensus. So that's why this particular thing is very important, and most of the times the correctness of the system or the correctness of the complete ecosystem of your blockchain is dependent on the consensus algorithms also. Okay, so these are some kind of the characteristics which blockchain is pertaining, and because of that, okay, we can probably use this, okay, in the IoT framework. Okay, and that is allowing us to have a greater kind of security enforcement on the complete this thing collection or the connectivity among the devices. Okay, yeah, so just to tell you a few more things, I'm not going into a deeper aspect, I'm just giving you the overview. So similar to the IoT architecture, we have a blockchain architecture also, and the purpose behind showing this to you, because when we want to say that like we are trying to converge blockchain and IoT, so this both architecture should be combined together so that we can have one seamless architecture wherein the blockchain is integrated into the IoT very seamlessly. So that's why if you see here, this is working on the top of the our network layer. So if you can see, we are having TCP/IP infrastructure and internet layers. Okay, then we are having here the blockchain layer, and in this blockchain layer we are having three layers. If you can see, we are having infrastructure and data layer, then we are having network layer, and we are having protocol layer. So in the infrastructure and data layer, the basic mechanism on which blockchain is working, okay, that those things are being present over here. So they are like, because we are using here peer-to-peer distributed network. Okay, so all the nodes will be seen as an individual entity over over there, and they are communicating with each other, or sometime it may so happen that they are simply doing the exchange of information with the help of some tokens, and they are maintaining the ledger at all the side, which is called as distributed ledger. And of course, whenever they want to take a decision, okay, or there is a way to take a decision that whether to go or whether to do these things or not. So that time the process which we need to perform is called as a mining. Okay, so I'll be showing you that in short time. And then the network, we are using peer-to-peer broadcast network. Okay, so the concept of the broadcast communication is being used over here. Whenever the message is being generated and broadcasted, again it will be sent to all or none. Okay, so that is the basic mechanism which is being used. And of course, there are multiple consensus algorithms depending on what kind of what type of blockchain you are using. Okay, in what environment you are using the blockchain. Okay, the different types of algorithms are being used. And then on the top of that, you are having the application layer, where you can have some kind of browsers or some kind of applications, or you can write some programming language constructs. Okay, majorly you might have heard about the terminology called as smart contract. So here, whatever transactions you want to do, which has to be, or operations you want to generate, okay, you can write those operations in terms of the programming constructs, and they're called as smart contracts. Okay, and of course you can write some decentralized applications, and using those decentralized application you can perform the transaction executions and all. And of course the wallet is being associated with that. Okay, because the basic terminology of the blockchain is whenever you want to do, or whenever you are performing some kind of mining or doing some kind of task, you are also getting a reward. And whenever you are participating, you need to also pay. So obviously every particular user is having an account wherein those particular this thing, like we can say currency is being stored over there. Okay, so that is one thing. And then on the top of that, you are having a presentation layer where you can use this on any kind of device like desktop, laptop, smartphones, or tablet. Okay, so this is a typical structure of the blockchain. Okay, I know that it is not really possible to tell each and everything in a short span of 2 hours. That's why I'm just trying to give you the overview kind of thing. Maybe by taking the inference from this, you can learn more, and you can try to get more insights about this. Yeah, so now coming to the next thing. So this is a typical categorization of the type of blockchain. See, over the period of time, I have seen that people wanted to use blockchain everywhere. Okay, but blockchain is not there for all the applications. So one need to understand where we can use blockchain. Rather, one need to understand where we cannot use blockchain. Okay, so if you know what kind of what types of blockchains are there, we can possibly understand what is the use of this, and where exactly we can, or whether in this particular application we can use this or not. Okay, so possibly there are two verticals on which we can divide these types of blockchain. One is based on the permission. So based on the permission, we are having permissioned and permissionless, and based on whether it is being publicized or it is being private to some organization, we are having public and private. And then we are having different types of this by combination. So we are having public permission, we are having permission private, we are having private permissionless, and we are having permissionless public. Okay, so normally if you see, the public means now here anybody can come and join. Okay, so now if I taking here permissionless and public, so it is a real blockchain. So here you can see this is the authentic blockchain, okay, which is fully decentralized, wherein anybody can come and join without taking permission. So it's a real public thing. So that's why here anyone in public can join and participate in the blockchain. Okay, similarly, if I say I have a public and permission, so now it is trying to combine public with permission. So now it is partially centralized. It will not become truly decentralized. It becomes partially centralized, because anyone in the public can join. Okay, they can read the blockchain, but only specific node who are having permission can create the transaction and write or append into the existing blockchain. That's why if you see here, or anyone in the public can join and they can read, but only the nodes who are meeting the pre-approved criteria, means based on some condition, the permission will be given to them, and then they only can write, means they can append. Write means they cannot modify. When I say write, it is append only. Okay, they cannot modify the existing blockchain, but they can add something. Okay, and when we are having the permissionless and private, so again it is partially centralized. Okay, and only the authorized nodes can access the network to read and write. So here, as it is private and it is permissionless, okay, here like in public, here anybody cannot join. Of course, only the authorized nodes can join. Okay, and they can access the network to read and write. So they should have some kind of permissions to perform reading and writing. And obviously the last one is private and permission. So actually the combination, this is when I say private and permission, so it becomes truly centralized. And that is against the basic fundamentals of the blockchain. And that's why we can say that it is not a true blockchain, because here only authorized and known nodes within the single company can participate in the blockchain. So the real freedom of blockchain is not being used over here. That's why this particular quadrant, if you can see, okay, this quadrant is not at all being used in practical. Okay, so people are working in this quadrant, and this quadrant. So this is a true blockchain where we are having permissionless and public. And here we are trying to put some kind of restrictions on reading and on writing. Reading can be possible, but writing we are putting restriction. Here we are trying to put a restriction on both reading and writing. As at the same time, the people can join, but they have to satisfy some preconditions over here. So now here we are having so many cases. Okay, we are having 3 cases over here, and depending on what kind of mechanism or what kind of application you are having, one need to decide which kind of blockchain has to be used. Okay, so this is all about the types of blockchain. Now coming to, as I mentioned, blockchain is a chain of block. Okay, so really, when the people who do not know blockchain, they are wondering like, what is so great in this? Okay, maybe multiple blocks are there and they're connected with each other. Okay, but the real things or the real crux is how exactly, what are the content of this block and how the linking is happening between those blocks. Okay, so if you see a simple structure of the block, okay, we are having the in one block we are storing multiple transaction, or maybe we are storing one transaction. For example, for simplicity, I'm taking one transaction, but there can be multiple transaction. Now I mentioned that we are using cryptographically secured mechanism. So here, whenever this particular a transaction list is being present, so this particular transactions, okay, they are stored in the blockchain. Okay, and obviously they can be encrypted and stored, but here there is a concept called as Merkle hash tree. So if you see here, I am having 4 transactions. Okay, so every transaction will be taken into consideration. Hash is calculated on that transaction, and it will be calculated in a bottom-up approach. And like you can see, transaction A, transaction B, we are getting hash A, hash B. These both are concatenated, and one more time hash is applied. Okay, here again these hash are calculated, they are concatenated, and one more time hash is applied. So we are getting this AB and CD as hash, and again these 2 are concatenated, and then we are getting a final hash, and that is called as Merkle root or root hash. So you can see that whatever thing you are storing in your blockchain, they are very, very secure. We know one of the property of hashing is, even you do a small change, even a bit change, okay, the complete hash which is resultant is modified. So here, even if you do one small change in this A, the complete hash will be modified. Okay, because it is again working from bottom up. So even if a small change happen over here, changes will happen. Okay, so that is one of the very basic mechanism which is being used over here. So now that transactions are taken into consideration, the Merkle root is calculated, and now that Merkle root, or that is called as root hash, that will be stored over here. Okay, and then we are having the other typical information like version information, the random number, which we are calling as nonce. And of course here, as we are trying to form a chaining, okay, so how do we form a chaining of the block? So basically those who are from computer engineering, or maybe nowadays people are from all the background, they are knowing about the linked list data structure. Okay, so we are trying to link one block with another block, and the next block address we are storing in the previous block. So that is based on the address. Here we are trying to use a hashing mechanism, and we are trying to store the hash of previous block into the next block. So if you can see here, this is a previous block hash actually. So if I am having here block number 98, block number 99, block number 100, and block number 101. So in this block number 101, the previous hash field will be containing the hash of the block number 100. I'll be showing you that in more detail. So likewise, we are trying to form a chain. So if you can see over here, the very first block, which is a starting block, which is a empty block, that is called a genesis block, which does not contain anything. And after that, we are having this blocks. So if you can see over here, this is the typical structure. This is a block data which are having transaction, which I showed you. And then we are having here the hash of the previous block. Okay, so this previous block is empty, but still, even if you are having space, some kind of hash you are getting over here, or we are considering this as a this thing, like we can say that this can be having some value, or maybe by default we are taking this as 0. Then we are having timestamp, we are having nonce, and then we are having hash of the block data. So this hash of the block data is nothing but it's a Merkle, what we have seen in the previous slide, and this is the hash of previous block header. Similarly, for this block hash will be calculated, header ka block hash, and that will be going to the next, that will be going to next, and this is how the chain is forming. Okay, probably you can see the chain is forming. So it's a chain of hash. Okay, and that's how we are saying that it's a blockchain. So it is not a merely chain of the addresses or this thing, it is chain of hash, and this is probably typically making the blockchain, okay, intact or satisfying the property of immutability, because even if you do the small change, okay, you can see the changes are happening. If I am doing change over here, okay, as it is going to the next this thing, here change will happen, here change will happen, and so on. So I'll just show you one simple demonstration so that you will get a flavor of this. Yeah, maybe now it is coming. Yeah, I was just about to show you like this. Yeah, maybe let me just show you the blockchain ka demo. So if you can see over here, I'm just trying to show you the 3 blocks. Okay, and here this is my first block, this is second block, this is third block. Okay, and this may contain, now in first block, if you see, this is showing me the previous block ka hash. Now as nothing is there previously, currently it is showing you 0. And now here I have a block number, I have a nonce, and maybe I'm putting here some data. Okay, suppose I'm putting here something. Now currently it is nothing is there, so I'm getting here the hash value. Okay, so the hash value is whatever data you are putting over there, that is hash value. So currently here space is there, and that hash value is calculated, or empty is there and the hash value is calculated. Now if you see this hash, whatever hash is calculated over there, that is appearing in the previous field of the next block, and that is how the connectivity is established. Here again, whatever data and nonce, all those things are there, new hash is calculated, and now this will going in the previous field of the next block, and that's how the things are getting connected, the blocks are getting connected with each other. Okay, now if you see, I just made a statement that even if you do a small change, it will change all the subsequent block. So even if now here nothing is there, now just I put here 1. So you can probably see one more time when I'm making here, I'm putting here 1. Okay, the changes are happening here, the changes are happening here, the changes are happening here, changes are happening here and here, and the color which was shown earlier as green, it was now turned into red. That means now the changes are somebody is trying to tamper that thing. Okay, so I'm just making here 1, and you observe. Okay, so this is getting changed. Okay, all these are getting change. So likewise, if I'm doing change here, this will change, this will change. So if I'm making here change, this will change, this will change. And if I make change over here, this hash will be changing. So likewise here, even if you do a small change, the changes are reflecting in the subsequent this thing. But of course, one can ask me the question that will the user allowed to do such changes? So no, this is just for a demonstration purpose. So you can see probably, maybe you can visit this site and see the demonstration later on. Okay, like it is showing you how this will be appearing on distributed environment also. Okay, and again the next concept which is being used as token and coin based, that will be also shown. Just here, as I just wanted to show you the basic thing, I just this thing, I'll be putting this maybe the web addresses in the chat window, okay, at the end of the talk, so that you people can use it. Okay, yeah, coming back to this. Okay, now, so this is a typical structure of the blockchain. Probably now, up till now, you might have understood that the things which are seen over here, okay, even though they are looking very simple, actually they are not simple. Okay, they are very complex. Okay, and obviously one can just ask me the question that IoT is already complex and blockchain is also complex. So what will happen when we are trying to add blockchain into the IoT? So obviously I'll give the answer to this at the end of the my this thing talk. Yeah, so this is the blockchain. I hope everyone has got the gist of this. And then we are having, likewise, we are having multiple blocks over here. They are added, they are connected with each other with the hash. And then we are having the chain of block. Okay, so blockchain is nothing but it's a chain of block, which are actually the chaining is established with the help of hashing mechanism. Previous block ka hash is being added into the current block to establish the chain and so on. Okay, now obviously the question will come in your mind that how the blockchain is working. Okay, so typically the typical scenario, we are trying to use a blockchain, okay, for doing the operation between two parties who are not trusting each other. Okay, so let's understand, suppose we are having A and B and they want to have some kind of transaction. When I say transaction, it is not actually a financial transaction all the time. It can be an exchange of information. Okay, so now A and B wish to have an interaction or a transaction. So now what they are doing, okay, so here first of all, as the first step is they wish to have a communication, or they wish to have some kind of interaction or transaction or operation. So next is the cryptographic keys are generated for them. Okay, and of course for A and B, for both private keys and public keys are being generated. Okay, they are known on the network with the help of their public keys. Private keys will be private to them. Okay, so both are holding that private key and public keys. So if A is having public and private, so normally by the concept of security, the public key of A is known to B and public key of B is known to A. Whereas private key of A is known to A only, private key of B is known to B only. Okay, and now what they are doing, whenever they are initiating the transaction, even though it is happening between A and B, so it is not the case that only A and B is in the network. There are multiple other nodes also there in the network. So whenever this transaction is initiated, okay, the transaction is now distributed, or it will be broadcasted to all the nodes which are there in the network. Yeah, already I mentioned how the validation is happening. Every node is having a ledger copy and they are validating that, and based on the validation result, of course, the majority principle will be used over there. And once that is validated, okay, then a new block is being created. So for that particular operation, once it is validated, a new block is being created. So you can see the block cannot be created unless and until the validation is happening. Okay, and now this block is created, and now this block has to be added into the existing blockchain. So maybe you are having the blockchain over here, and this block is added to the chain, okay, and creating a permanent golden source of interaction. So now once the validation is done, block is created and block is added into the blockchain, means the block, that particular transaction is executed and that will be added on the blockchain. And once it is added, it cannot be modified. And that's how we can say that the transaction between A and B is happening. So now even if A and B has done the transaction maybe 5 years back, this is there on the blockchain. Okay, nobody can modify it. So whenever they want to see it, they can go and see. They can read it because it is readable. Anybody can go and read that particular blockchain. Okay, so that is how the blockchain is working. So now when we want to use this in IoT, okay, we are having two maybe the sensing devices which are talking to each other or exchanging the information. So now we can assume A can be one device and B can be other device, and they are now trying to have an interaction. So such kind of mechanism is being used over there. Okay, yeah, and just to give you the flavor of where exactly the blockchain is being used, so you can just see for a minute and see that almost in every applications, wherever the exchange of information happens, okay, there blockchain can be used. So it can be financial applications, or it can be a non-financial application. Everywhere, wherever you are having exchange of information and multiple parties are involved, there you can use blockchain. Okay? And one of the this thing application which we are trying to focus is the IoT. Okay, and you can have a lot many things. I just tried to put here some things so that you can get a flavor of this. Okay, you can go through this later on. Maybe I'll be passing the slides to organizers. Yeah, yeah. So when I say yeah, so now A and B wants to do the things, and they are they want to perform a transaction, and now that transaction need to be validated. Okay, so the validation process also we have seen. Okay, now we need to understand one very important concept called as consensus. Okay, so as I mentioned earlier in the characteristic, this is one of the characteristics of blockchain. So it's a common agreement which the complete group is taking or performing, and based on that, okay, the decision will be taken. So everybody is putting their opinion, and whichever is a common opinion, that will be taken as a final action criteria, and the action will be taken. And once this is finalized, or once the majority happens, or the common agreement happen, everybody has to follow it. Okay, so basically we can say that it's a protocol in the blockchain which is being used in the blockchain. Okay, which is being a complete set of rules and regulations we are having, procedures we are having, so that the unified agreement should happen between the participating nodes of that particular blockchain network. Okay, now basically how this particular consensus is happening, I'll be showing you with some simulation so that you can understand. And this particular consensus is, first thing, it is providing a unified agreement that anonymously the agreement is happening, everybody has to follow it, fault tolerant. Okay, of course in the environment, in the network, sometime it may so happen that some of the machines are not working properly, but as it is following majority principle, so always the consensus is what we can say a fair one. Okay, and it is collaborative and participatory. All the nodes are participating in a collaborative way. They are working, and they are actually coming up with a common decision. Okay, then we are having, as I mentioned, fair decision. So it's a fair decision. And then incentivization, depending on the consensus. Okay, some kind of incentives are being given. Okay, so there are many algorithms or many mechanisms through which the consensus is happening. So based on what kind of terminology they are using, the incentives are being calculated and given to the nodes who are actually winning that particular thing. Okay, and of course it is preventing double spending. So this is one of the problem. Maybe if you are not having such kind of scenarios, it may so happen, because we are considering that it is not a trusted entities network. Okay, so maybe if I am having $100, I can pass that $100 to A, and I can pass $100 to B, because there is no trusted entity, nobody is there to see. So I have only 100 rupees, but I am spending it twice. I'm giving it to A as well as I am giving it to B. But now using this consensus mechanism, okay, it is trying to catch hold of this double spending, and it is preventing double spending. So if you try to do that, of course, here as all the nodes are participating in the validation, okay, even if you try to do it multiple times, it will be validated only once, not for the multiple attempts, and those transactions will be invalidated. So like it is trying to prevent the double spending. Okay, so these are the objectives of the, or we can say these are the characteristics of the consensus, which is making the system more stable and more efficient. Okay, now just to show you how the consensus is working. Okay, so if you can see, I'm just trying to show you that maybe this is the already existing blockchain, okay, where you are having one block which is having this many transaction, then we are having second block which is having this many transaction, third block having this many transaction, and now suppose a new set of transactions are coming. Okay, so this miner is coming with this operation, this miner is coming with this operation, and this miner is coming with this operations. So now here, how do they proceed? Okay, whether the transaction which are proposed by this miner should be executed and added into the blockchain, or the transaction which are proposed by this, or the transaction which is proposed by this. Okay, so the strategy which they were using is, okay, one particular challenge will be given to them. Okay, and they have to solve that challenge, and whoever is solving that challenge, okay, earlier, that will be the winner, and that will get a chance to actually perform this transaction. So maybe suppose, for example, this is miner 1, miner 2, and miner 3. Okay, so all of them have given some puzzle, okay, some challenge, and he is solving now, and that challenge is computational intensive challenge. So now this is solving, and this is solving. Maybe he could solve in 1 second. He is still solving, and he is still solving. So as soon as he solved, he will announce that I have solved it. Okay? And the puzzle is actually interactive puzzle, and it can be verified whether it is solved or not. Okay, so now whichever the miner or the node who is able to solve that particular puzzle, okay, the transaction which are proposed by that miner, that will be taken as a candidate transaction for adding into the blockchain. But of course here, if they are validated. Okay, so now here the block is accepted for the miner who can prove first that the challenge has been solved. Okay, so now say for example, this miner has solved that challenge first, so these transactions can be taken into consideration for adding into the block if they are validated. Okay, now for validation, again they are sent to all other nodes, they are validating, and if they are validated, then only the block will be created and added into the blockchain. So just to show you the simple, yeah, so I was mentioning that one of the miner, he is getting a solution. So as soon as he get a solution, he is broadcasting that message that I have a solution. Okay, and he is sending that solution also, and the puzzle is known to everybody, so they will be trying to check whether the solution is correct or not. Okay, and once the message is obtained by them, they are verifying. Okay, and they will stop solving that puzzle because somebody has already owned, and now this transaction set can be considered for adding into the blockchain. Okay, so let me just give you the scenario, like how the things are working. Okay, so now here, as you have seen here, so this block is getting added in the blockchain. So I'm showing over here. So this block is getting added into the blockchain, and then probably next set of transactions are coming in picture, and the process will be repeated. Okay, so just to show you how the things are working in the blockchain, how the consensus is working. So this is already existing blockchain. I have shown you the structure. So if you can see some of the parameters which we need to understand, here we are having a nonce value. In every block we have seen nonce value was there, and we are having previous block ka hash that will be shown as PH, and nonce value will be shown as N. Okay, now these are the 3 set of transactions which are coming in the system, and now the decision has to be taken. Okay, which set of transaction need to be added. Okay, so now what is happening here? One puzzle will be created. So again, this puzzle is called as, this is a hash friendly puzzle. And what is that puzzle? This previous block hash is known. Okay, this is the previous block hash. This is known, so this will be written. Now here, these are the transaction, or maybe these are the transaction. The transactions are already available. So the transactions will be taken and Merkle root will be calculated. So Merkle root is also available, and this nonce. Okay, so now what the challenge over here is, okay, the miner has to find out the nonce value, okay, in such a way that concatenation of that nonce, this Merkle root, and previous hash. Okay, so hash of the concatenation of these three should result, okay, into the hash with some specific criteria. Okay, so I'll just go and show you over here. For example, here the criteria is I have to select a nonce in such a way that the calculated hash coming over here, it should have first 4 digits as 0. So challenge is this, okay? The nonce has to be found in such a way that the hash of concatenation of previous hash, Merkle root, and that nonce should create a hash which should have first 4 digits as 0. Now it is not so simple to find out that nonce. Okay, lot many trial and error combination has to be done. Okay, and now this particular miner has to solve this puzzle. Means he has to find out such nonce value which will be resulting out in BH, which is having first 4 digit of the hash at 0. Okay, so now here he is solving, he is also solving. Okay, and it's a computational intensive task. You can imagine how much time it will take, because the nonce value, again, it's a random value. So one by one, different nonce has to be taken, and hash has to be calculated and seen whether it is giving first 4 digit as 0 or not. And that is called as a mining difficulty, actually. So here, every miner is trying to do that, and maybe one of the miner is winning. Okay, so say for example here, I'll just going back and say for example this miner is winning in that case. So again, previous scenario what we have seen, he will be declaring that I have a solution, and he's sending that nonce value also to all this. And now they also know this puzzle ka algorithm, so they will put that nonce and verify whether first 4 digits are coming at 0 or not. So they are verifying, and once the verification is done, now he will be declared as a winner. And now as he is declared as a winner, the transaction which is proposed by this miner, okay, those transactions are eligible, or they are the candidate transaction which can be added into the block. But the next procedure is all this transaction need to send to all the nodes, validation will happen, and then once the validation is happened, this transaction will be executed and added into the block. And that's how the blocks are getting added into the blockchain. So this consensus is playing very important role in the blockchain formation. And here, when I say we are using here the hashing concept, and also the private key, public key is being used over there. We are using encryption of the transactions also. Merkle root, Merkle hash tree is being used over here. So at different level, multiple time, we are making use of this security mechanisms, which is making it more and more secure. Okay, but one thing we need to note, the complexity is getting increased. That's why if you see executing the things on blockchain, okay, of course on simulator you can easily do that, but installing the blockchain on your system and doing the things, it is really very tedious and very complex. You really need a patience to do that thing. Okay, so this is how the consensus is working. Now coming to the scenario, because we have to see how this blockchain is being used in the IoT framework. So before that, we need to understand, okay, where to use blockchain. So now I have some questions and answers for that also, which will obviously help us to decide where to use blockchain. Okay, so now if we are having multiple parties in the system, okay, obviously, if you are having multiple parties involved in the system, we can use a blockchain, because we want to establish a secure operation exchange, okay, between these parties, and that's why we can use this. And maybe the network which we are using for communication, that network is not secure, so there we can use a blockchain. Now the second question is establishing trust between all the parties and issue. Okay, because blockchain, of course, we have seen the characteristics that blockchain is a trustless. Okay, but it is providing inherent kind of trust by enforcing all such kind of mechanism. So blockchain is trying to improve the trust between the participant by having multiple points of verification. If you are seeing multiple, every time it is being sent to all the nodes and they are doing validation, so all the time these things are happening. So even if these two parties, they do not trust each other, okay, but this blockchain is trying to provide a mechanism okay, through which they can do some kind of operations among them without involving any trusted third party. Okay, and of course, the next question is it critical to have a tamper-proof permanent record of transaction? Okay, so we want to keep all the record of the transaction which we are performing. If answer is yes, then of course we can use a blockchain over there. Also, the question is, are we securing the ownership of management of a finite resources? Of course, here, whether you want to preserve the ownership and you want to prove it as and when it is being challenged, okay, then if you want to do that, of course, the answer is yes, you can use a blockchain over there. Okay, and of course, the last question is, does this ecosystem benefit from improved transparency? So now, basically, if you want to provide or establish a transparency, okay, that because blockchain is by default, it is providing you transparency. Anybody can come and read the content of blockchain. Of course, they cannot modify, but they can read the content of blockchain. So by design, it is transparent, and wherever we require such kind of transparency, we can use a blockchain. So now by getting answer of this question, we will definitely come to know where to use blockchain. So wherever such scenarios are there, we can use a blockchain. Okay, and of course, now coming to the real business, that how we can integrate blockchain with IoT. So already I mentioned that we had a perception layer in the IoT architecture. Okay, then we are having a transport layer. We were having a network layer in the IoT this thing. So that layer is put over here as it is. And if you see, on the top of this, we were having application layer. So now what we are trying to do when we want to have integration of blockchain and IoT, so here we are trying to just introduce one more layer between this transport layer and application layer of IoT layer. Okay, so if you can see over here, I have shown you the blockchain layer also and IoT architecture layer also. This 1, 2, and 3, these are the IoT layers, and this is my blockchain layer, which I am trying to add between this with some modifications. Okay, so here maybe in the blockchain layer, I'll be having data and infrastructure sub layer where I'll be using some basic constructs of the blockchain which I require, like the block mechanism, the hashing mechanism, the propagation protocol, the verification is happening, the encryption mechanism, and of course storage. And then on the top of that, we are having a distributed communication sub layer which is taking responsibility of collection of the transaction. Okay, and then collecting all the transaction, then performing the consensus, and if needed, performing the replication and all those things. And then of course we are having the application part over here. We are having a platform sub layer which is basically working as an agent. So we can have a RPC, we are having web APIs, or we are having REST APIs which are working on the top of IoT, and they are trying to give you the it will try to give you the environment wherein one machine can interact with another machine for securing the communication with the help of this. And of course, we are having, then we can write a smart contracts, okay, to do all those things, because basically smart contracts are nothing but you are trying to write a script for establishing or for simply writing the transactions, and you are providing the environment or a condition environment based on which the transaction will be executed. And of course, here we are having blockchain as a service. Okay, so you can have a sub layer which will simply work as a service mechanism, and therein blockchain can be simply being used on the top of IoT, and which will work. And of course, digital asset management is there. If some nodes are getting connected with each other, and or multiple nodes are there, somebody is winning and they are getting some rewards, and of course the things need to be managed, and that's how this layer is working. So seamlessly we can add this layer, but it is not so easy. This is at the theoretical level I am telling you. Of course, when we are implementing this, you need to consider lot many, you have to face lot many constraints and challenges, and that has to be tackled based on what kind of applications you are using. And of course, you are having on the top of this, you are having the application layer, and here you can have different applications for which you are basically using the existing IoT architecture. right? So this is how the things are working. Okay, and yeah, so now just I'm not going into much more detail because again it will be taking more time. So I'm just giving you the hint. Maybe those who want to do some research in this field, they can just explore and try to find out how exactly the things are working. So basically, as I am trying to use this blockchain in the IoT, we need to see that what kind of benefit blockchain is providing to IoT. Okay, so we have seen various kind of attacks earlier. So let me go back and show you one more time. Okay, so I have shown you this attack, and now I'm just trying to show you, okay, various characteristics of blockchains which we already seen. We have seen decentralization, we have seen the persistency. Okay, means we have seen like it is immutable, then anonymity, then scalability is also present over there, a resilient backend, then we are having high efficiency, transparency, we are using smart contract, and non-repudiation. Once you have added a block, okay, you cannot deny that I have not added the block in the blockchain. So these are the characteristics of blockchain. So now here, when you are trying to find a solution of this attack, because fairly we want to establish or we want to use a blockchain for getting rid of this kind of attack. So now when we are trying to get rid of this attack, say jamming adversaries, so maybe the blockchain characteristics which we need to take into consideration are maybe the decentralization, the efficiency, and traceability. Okay, likewise here you can see the complete table is there. Okay, so probably you can go and see one by one. So possibly I'll take one more example. For example, here insecure interfaces. So maybe you can have a decentralization, then you are having anonymity, then you can use probably the what we can say efficiency, and of course the smart contract and all. So likewise, one can use all the characteristics or some of the characteristics depending on the need of that particular. Okay, but when we are basically establishing the blockchain, all these are coming by default. Okay, so likewise, this you can see. Probably if you are interested, you can just see this is one of the work which I have published. So in that paper, you can find it out. Okay. Yeah, coming back to this. So now all in all, we can say that the benefits of the blockchain in IoT. Okay. So very first thing is they are providing you high data security. So whatever the data is being generated by the end devices, the sensors of the IoT framework, those data is being passed to some other component, and there we are saying that the exchange is happening. So we are trying to put that thing on the blockchain. So that's why we are saying that we are trying to establish a high data security. Then it is providing you a stronger data validation process. We have seen the validation is happening multiple times by considering all the nodes consensus, and that's why it is providing us stronger validation. We are having better quality control in IoT manufacturing. Obviously, this particular point will not really go in the security perspective, but of course, from the point of the quality control, you can possibly see what kind of data is being generated by that IoT device, because all the time it is being put on the blockchain. So you can verify, and of course, based on that, you can tell the manufacturing company that how the things are working, and some kind of decision can be taken. Of course, here the benefit is it is trying to establish the secured environment over there. So basically it is working as a firewall also, because even though some kind of DDoS attacks are happening, it is trying to cope up with that, not every time, but it is trying to work as a firewall against the DDoS attack, because every time we are using a consensus which is working on a majority principle. So that's why it is working in that way. Of course, secure communication gateway. Okay, real-time tracking can be done. Okay, once I said like we are having this the chain like from one device to the local receiver, it is going from local receiver, cloud it is going, and from cloud the client application it is going. So the complete tracking you can perform, okay, with the help of this blockchain, as you are putting everything on the blockchain. And of course here you probably can use over here the encryption, which is fairly being used for multi-factor authentication over there. Okay, so that such kind of thing can also be used. Of course, here the better access control mechanism is being used, even though it is trying to provide you anonymity. The public key and the things are very like used in an efficient way. So it is trying to provide you access control mechanism also, depending on what kind of blockchain you are using. of course, the permissions are given to you for read or maybe the to see that particular blockchain or add something into the blockchain. And of course, here better compliance management. So these are some additional advantage which we are getting. Data anonymity already I told, user anonymity is also there. Then stronger cloud management is there. All the communication, everything is being recorded. They are tamper proof. That will help to manage this cloud management or store management is better way. End-to-end visibility is there. Who is sending what to whom, that can be easily found out, and that will be helping us to find out end-to-end visibility. Then better automation process. So if we are taking the application like smart irrigation or smart transportation, so the automation process is becoming better if we are using such kind of mechanism, because we don't need to worry about the all this aspect. It will be automatically taken care by the blockchain. And of course, the identity of IoT devices. Even though I am saying the anonymity, so really it is not a typical identity of the IoT devices, but each and every device which is working in the environment, they are having a traces in the blockchain. So you can possibly see that which devices are working and which are not working, and which are just lying as a ideal devices in the system. That can also be done. And of course, one of the very important benefit which we are getting when we are integrating blockchain with IoT is efficient supply chain. Okay, so normally we want wherever we are having supply chain, we want to have a transparent system to see that who have done what. Okay, and at any point of time, if you want to see that, we should able to see, and blockchain is providing us a way to do so. Okay, and that's how these are some of the benefits of the blockchain when we are trying to integrate this with IoT. Okay, but we have the other side of the coin also. Okay, so when we are trying to establish, or when we want to convert, we are trying to converge this blockchain with IoT, as I mentioned, it is not so easy task. Okay, and lot many challenges are there. Okay, the very first challenge is, you can see the scalability. Okay, and those who are from IoT background, they might be agree with me that the IoT devices are very small devices. They are limited in a memory capacity. They are limited in a computing capacity. And whenever such kind of consensus algorithm need to be executed, they require a computational intensive. They are computational intensive tasks, so computing power will be more. So it's a really trade-off between that. Okay, that's why if you see the consensus algorithm, which I told you, okay, that is typically called as proof of work consensus. But when people are trying to use blockchain for the IoT environment, they are not using that POW as a consensus, because it is very heavy consensus algorithm. So people try to find out some lightweight consensus algorithm, and maybe you might have heard about IOTA, or maybe the Tendermint, and there are many other consensus algorithm which are the lighter version of the existing consensus algorithm, which are typically invented by the people for IoT environment, so that it requires a small computational power, or it takes small computational power, and it can be executed on small tiny IoT devices also. Okay, so that is one thing. Security risk, of course, here, as you are having very small devices, so you cannot do all the things on the devices. And basically, if some of the devices are not able to handle it properly, then maybe if somebody can just try to tamper with the device, okay, by playing with some firmware and all, then typically the things will go wrong in the different way. Okay, and of course, sensor reliability, that is also one case. So that is again connected with the previous one. Okay, the network privacy and transaction confidentiality. Okay, so again, as different networks are being used over there, different people are managing those networks. So typically, the interoperability and the standardization and all those things are really playing very important role, and that is still a challenge over here. Okay, then computing time and computing power I already mentioned. Okay, that most of the consensus they are taking lots of computing power and time, and because of that the things are or the system becomes so complex and it will not happen within a time which is required. So that's why people try to invent some of the lightweight consensus algorithm, and that's how the people that's how it is working in a proper way. And add on complexity. So just see that whenever we are using blockchain, so to add one transaction in a block, lot many things has to be done. Okay, so it is trying to add extra complexity in the existing IoT infrastructure. But apart from these challenges, okay, there are many advantages also. So that's why people are trying to put all those things into consideration, and they try to develop a solution. Of course, they try to find out the solution on each and every challenge, and they're working with the solution which are giving, which is resulting out in a less computational power, computational time, as well as the less complexity, and of course at the same time giving the better security and more security. So that is how the things are working. But still, if you see in today's world also, there is no sustainable, or we can say a mature convergence of blockchain in IoT. People are trying in different way, and they are coming up with a solution, and depending on what application you are working, different solutions are there. So now typically I am just showing you two things over here. Okay, this is how we can converge the blockchain and IoT. So if you see now, I have this as a supply chain. Okay, now this supply chain may involve multiple entities, it may involve people, and it may involve devices. Okay, now when we are trying to establish a connection between this, so here a transaction is happening, here a transaction is happening, here a transaction is happening, and here a transaction is happening. So all the time when the transactions are happening in the supply chain, and they are connected through a IoT network. So we are having IoT network management also. Okay, we are having all these end users are working. They are dealing with the authentication, end user authentication. Then we are having on-demand asset sharing network also. Okay, depending on what kind of application you are taking, this may be changed. And to integrate all these things, okay, we want to simply, we have to take into consideration that we want to we want to establish a security in, during the interaction which is happening among this entity, okay, with the help of transaction. Okay, and that's why here all the time you are trying to write a smart contract and compliances, and using that the transactions are getting executed. Okay, and one last this thing I just wanted to show you. So this is a typical case study, okay, wherein multiple parties are involved. So just to tell you, like we are having here 4 entities. We are having farm, or maybe farmer, you can see. We are having transport system, we are having a store system, and we are having business application. Okay, so when we are starting, say for example, some crop is now coming, okay, some yield is coming over here. Okay, so that will be taken out by the farmer, it will be scanned. Okay, then here maybe you can see all the places you are having some kind of IoT gateways. Okay, you are having IoT edge gateway, here you are having some IoT edge, here you are having some IoT edge, and again, and all the places. So this is smart integration of IoT as well as blockchain. You can see the gray lines are showing the communication which is happening in IoT network, and the orange lines, they are showing you the communication which is happening in the blockchain network. So everywhere the blockchain is getting integrated. So here we are trying to write one distributed applications over here, application, and everywhere at this node we are having a copy of blockchain. At this node we are having copy of blockchain. At this node we are having copy of blockchain and copy of blockchain. And now here we'll be getting whenever the transactions are happening, okay, these distributed applications are helping us, and using that the things are getting added into this blockchain. And merely here we are having all these things are connected to the IoT platform, where maybe we are having some IoT data, or maybe we are having digital twins and all, and likewise the things are working. And possibly if you can see here, every time whenever the communication happens, so from this to this the communication is happening, that means the transaction is happening. So all the transactions are written with the help of smart contract. You can see on the top of this is a smart contract, so everything has to be written in the smart contract. Okay, then here also when the exchange happen, Okay, this is happening through this IoT platform. So again, this exchange will be scripted over here. Okay, and this with this distributed application, it will be added on the blockchain. And likewise here, you will be getting the complete communication between all these 4 endpoints, and everything will be securely managed. Okay, so likewise we can have, and this is a complete blockchain peer-to-peer network where all these are acting as 4 nodes. Okay, but apart from this, we are having other nodes also which are coming into the picture, which are part of this IoT platform, and they are also participating in this. And you can have a different, like we are having a logistic company. This is a transport, so logistic details. If you want to see logistic detail, you can just see the blockchain and find out. You can find out, you can see the retail chain also, because now once it goes to store and the other places, it becomes retail, that you can see. And maybe these are the business applications which are being used for developing the front end and all those things. So that will also come in picture. So likewise here, this is just I'm just trying to show you how the things are working, but really in practical, it is not so easy. But there are many such things available nowadays, and people try to use it. And in many of the environment, people are successful to build the blockchain environment integration in the IoT. Okay. So coming to the last point, what are the research challenges in this? So as I already mentioned, basically the IoT, this thing that will be handled by the core group of people who are from a different background, and maybe the blockchain, this is coming from the security domain, and the people who are handling this, they are different. So always there is a gap between the domain knowledge. So when we want to converse these 2 things together, if the proper knowledge sharing and proper discussion doesn't happen, okay, or the interoperability and all those things are not studied properly, of course the solution will not be a sustainable solution, and always there is a gap. So first of all, there is a huge requirement of filling the gap between the IoT and blockchain community. Then the second thing is, as I already mentioned, that we cannot use a very heavy consensus mechanism in the IoT, because we are having small devices, they are having less computational power and all. So we need to devise a lightweight yet secure consensus mechanism. So of course, lots of research is currently being done in this field, and maybe if you want to take it further, there are many consensus protocol which people have already invented for IoT. But depending on what application you are using, you can invent your own consensus algorithm also. Okay. Of course, here, whenever you want to use IoT, blockchain in the IoT, merely you cannot just take a technology and converge it with IoT. You need to understand the complete ecosystem of the blockchain, how exactly it is working, and whether it can be used for that application or not, whether using this will really solve the purpose or not. And based on that, you can possibly understand, possibly apply that particular this thing, or converge blockchain with the IoT, or use the blockchain in that IoT use case or application. And of course, here, as there are complexities, there are heterogeneity in physical network application component. It may be a sensors, it may be a actuator, your network components, your network protocols. And as there are different devices, different protocols, so different vulnerabilities are there, weaknesses are there, and of course they are resulting out into different kind of attacks. So one need to understand the complete heterogeneity of all those things, and try to find out the solution on that. So still people are trying to find out solutions, so one can contribute in this field and try to give some kind of research contribution in this. Okay. So here I come to end of my talk. I hope I could give you a small knowledge on blockchain and how we can possibly use it in IoT. If you're having any question, now I'm ready to take the questions from participants.
Yes, participants, please ask questions. Participants can post the questions in message box too.
Yeah, I hope they understood what I tried to convey. And maybe they will go through the things. And if you are having any questions, you can probably put in offline. I'll be just putting the link over here for the demo which I use. And this is
Ma'am, we are getting the response is very, very nice. That the explanation was so good that means the concepts are very much clear, ma'am. So this is very nice for our debate. The participants are also very happy to get know regarding the blockchain and IoT relations.
yeah, probably I can expect that they will go through the things, and maybe if they are having some kind of difficulty, they can connect with me then. Yeah, thank
Yes,
you
ma'am,
for
yes.
patient listening, and thank you for giving me opportunity to share a knowledge with the participants. Yeah, thank you.
Yes, thank you so much, ma'am, for your detailed insight regarding IoT and blockchain, regarding the various convergences, various algorithms you have explained. Those were really will be helpful in implementing such technology, in studying such technology in detail. Thank you so much, ma'am. I request all the participants to please switch on your video. We will have a group photo now. All the participants. Yes, everyone ready? Okay. Once more, sir. Yes, it's done. So thank you so much, one and all. Thank you so much, Lata ma'am. It is really a very nice session we had now. So, ma'am, Nidhi ma'am, next session will be on just a gap of 10
Yes.
minutes. Na?
Yes, we can take break of 10-15 minutes.
10 to 15 minutes, yes, please.
Yes. Then Bishnoi sir will join around 4.
Yes.
Thank you all. Bye.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you, ma'am.